So factoring by grouping works by taking four terms, like any of the four listed below, first grouping them into two groups in the hopes that you get a similar pair of groups that you can then factor out. All right, let's take a look by example here. I'm going to look at the first two terms in each of these groups. Now, before I go much further, let me explain why I must factor by grouping. I'm going to factor by grouping because if I look at all four terms together, there's nothing in common. I can't divide all of them by 2 because of this first term. I can't divide all of them by x because of this last term. I can't divide all of these by 5, or all of them by 2, or all of them by x. There's nothing in common with all four terms, so there's no GCF out of everything. So instead, I'm using this factor by grouping method. This is a new method. So how it works is I look at the first two terms, and I say, okay, what's in common? The first two terms, so we are ignoring the other two right now. The first two terms have an x in common, so I'm going to take the x out. When I take the x out, that's going to leave us with 1x out of the first term, leave us with an x. The x out of the second term will leave us with a 2. Alright, now we come back and look at the second two terms. Cover up the first two. The second two terms, when I look at them, they have a 4 in common, a positive 4. So I must put the plus here since it's really in the middle of the expression. So plus 4. And when I divide that 4 out of the first term, it's going to leave me just the x. And I divide the 4, the 8, plus 2. Alright. The whole thing. Okay. So what we notice is that when I factor this by grouping, I have two groups now. And in each of those groups, there's an x plus 2 in common. So I'm going to factor the x plus 2 out. So it's going to leave me with x plus 2. And when you take the x plus 2 out of the first group, you're left with x. And out of the second group, you're left with a positive 4. And that is my end result. This has been factored by grouping. Right. Now if I wanted to get back to the original expression, I could distribute x times x is x squared, 2 times x is 2x, x times 4 is 4x, and 2 times 4 is 8. Okay, so if I distribute by multiplying each term in the first parenthesis by each term in the second parenthesis, I will get to the similar result, or get to the same thing that I started with. Okay, and let's try it one more time over here. The first two terms have a 5 and an x squared in common. So if I take that out, I'm going to be left with just an x and then a minus 3. The next two terms have just a 2 in common. And if I take that out, I'm going to be left with an x minus 3. Now you can see that both of these new groups have an x minus 3 in common. So if you take that out, you're left with a 5, x squared, and a positive 2. Right? And that's factored. Alright, let's look at our last two examples here. The first two terms have a 3 in common. If I take that out, it leaves me with a minus b. And the second two terms have a x in common, but notice that the first one is negative, so I'm going to be factoring out a negative x. A negative divided by a negative is a positive a positive divided by a negative is a negative b. So a minus b is in common. When I factor that out, I'm left with 3 from the first term minus x from the second term. And the last example. The first two terms have 3 and x to the third in common. If I take that out, 12 divided by 3 is 4. X to the fifth divided by x to the third is x squared. Minus 21 divided by 3 is 7. X to the third divided by x to the third, all the x's have already been removed. Alright, in the next grouping, 4x squared minus 7 has nothing in common. I can't divide 4 and 7 by any number but 1, and they don't both have an x. The only thing I can take out of those two terms is a 1. But if I take out a 1, it's going to be 1 times 4x squared minus 7. That's enough because these parentheses are the same. So I'm going to factor that out. 4x squared minus 7. Out of the first term, we took out a 3x cubed. And in the second set of terms, we took out a 1. That's completely factored.